In this video, let's review integration by parts, and this time we have a log in there. Okay, so first I'm going to evaluate the indefinite integral. So we're trying to evaluate square root of y, natural log of y. Now, what we're going to do here is use what's called a tabular method, which means that we're going to create a small table here. We're going to have a d, which means differentiate, and I, which means integrate. And then we need to decide which of the two factors would go where. And to help us with that, we have a mnemonic rule that is called LIPET. So it's LIPET, log, then inverse trig, then some kind of power, then exponential, and finally trig. Now, what does this mean? It just tells you which function goes where. So whichever function comes first in the word LIPET, that goes in the D column. Now, here we have square root of y, which you can think of a power, y to the power 1/2, and natural log. And natural log always goes in the D column. It's never going to go in the I column because it's first. So this is going to be natural log here. And then the square root is going to be in the I column. Okay. Why would it not make sense to put natural log in the I column? Because if you did, you would have to integrate it. But how do you integrate it? Now, a common mistake is to say, well, integral of natural log of y is 1/y. Well, that's not right, because actually that's derivative. Okay, so you can't do that. Okay, so let's take the derivative of natural log of y. That's 1/y. We just said that. What about integral of square root of y? Now, in order to integrate a square root, what you would have to do is take the y and raise it to the power 1/2. Now, you haven't actually integrated. All you did is you said, oh, square root is actually 1/2. Okay, and then you have to use the power rule, which means that you would have to add 1 to the power, so that becomes y to the power 3/2, and then you divide it by 3/2. Okay, you always divide by whatever you get in power. So 3/2 is 1/2 plus 1. Now, dividing by 3/2 is the same as multiplying by 2/3. So the final answer there is going to be 2/3 y to the power 3/2. Okay, so let's write that here. 2/3 y to the power 3/2. Now, we are done with the table. Why we're done? Because does it make sense to continue doing it? So you only keep doing it if it makes it easier. So let's say if you started with something like y squared, eventually in the D column you will get to 0, which is good. But here, if you try to differentiate again 1/y, which is y to the -1, that's going to give you -1 y to the -2. So and then this guy is going to become 5/2. It's like there's just no point of doing it again. Okay, so what do? You also alternate signs in the table. So let me see if I can just fill this out here. And this is going to be square root of y. This is going to be 1/y, and then this is 2/3 y to the power 3/2. Okay, so we got that out of the way. Now, what do we need to do for the tabular method? You were supposed to multiply diagonally across. So that would be the first term in your answer. But the second term in your answer is going to be the integral of the box. So what do we mean by the box? We always mean the last row and the product. Actually, the product of whatever we see in the last row, including the sign, which is a negative. Okay, so what we need to do is integrate -1/y multiplied by 2/3 y to the power 3/2. Now, another sort of rookie mistake is to see, oh, I have a product, so I'm just going to integrate this guy, and I know that that's natural log, and I'm also going to integrate that guy, and that's going to become blah, blah, blah times y to the power 5/2. This is a horrible mistake. If you ever do that, your teacher is going to be like, oh my God, you can't do that. There is no rule like that. I wish it were. Then half of Calc 2 would just disappear because there's nothing to do. No, you can't integrate a product as product of integrals. That does not work. So what can you do? Well, what you have to do is combine this guy with this guy. Okay, so what will happen? So let me actually take out the negative and 2/3. You can always pull out a number from the integral. And then think of 1 over y as y to the power 1 on the bottom. But when you move it to the top, remember that that's just the definition of negative power. So here you got y to the power -1 multiplied by y to the power 3/2. Next, you are going to use the rules of exponents. And one of the rules says that if you have the same quantity raised to different power, we just add up the powers. Okay, so you've got here 3/2 and -1, and we add them up. Okay, so -1 is -2/2 plus 3/2, that's 1/2. But we already know how to integrate that because we did that in here. So we got 2/3. So we're going to have another 2/3 because we just integrated that over here. This is what we got. And then we have y to the power 3/2. Okay, so here I just integrated what's called the box, and I got -4/9 y to the power 3/2. Okay, so I'm basically done. Now I have to do the diagonal multiplication. So multiply the first element over here, which is natural log, with the second element of the I column, including the sign, but the sign is positive. Now we usually write the powers and the numbers in front of the log. So there's no confusion that the log does not, like, you can't insert y to the 3/2 inside the natural log. You can't do that. Okay, so natural log is natural log. It's just some number. Okay, and then you are gonna also add integral of the box, which is actually in this case subtract 4/9 y to the power 3/2. Okay, so that's your answer. That would be the indefinite integral. Now, what happens with the definite? We are just gonna substitute the limits. So let's see what happens. So I'm gonna have 2/3. Obviously, don't substitute it in the integrand, and we substitute it in the answer, in the antiderivative. So we're going to take that, whatever we got here, and we are going to substitute the limits. First, we always substitute the top limit. Okay, so the top limit is 49. So let's do that. So it's going to be 2/3. Then it's going to be 49 to the power 3/2. Then it's going to be natural log of 49 minus 4 divided by 9, and then 49 to the power 3/2. Okay? Then we subtract, and then now we're going to substitute 1. Now, what happens when I substitute 1 in the natural log? So here I'm going to have 2/3, 1 to any power is 1, and then I'm going to have natural log of 1 minus 4/9, and 1 to the 3/2 is 1. Okay, one thing that every calculus teacher will be very mad at, if you leave the natural log of 1 in your answer. You are supposed to know that this guy is actually 0. So if you do not know that, then go to Desmos or whichever calculator you have and just enter natural log of 1. And it'll tell you that that's 0. Now, what else we want to simplify? We also do not want to leave 49 to the 3/2 there, because this is actually is square root of 49, but then you raise it to a power 3. Square root of 49 is 7, and that's going to be 7 cubed, which I think is 343 if I'm not mistaken. But you can of course always just enter it and it's going to give it to you, but don't leave it like that. Okay, so you got 2/3. Then you have 343 natural log of 49. Now you could simplify this using properties of logs, because 49 is 7 squared. So you can actually take the 2 and move it outside of the log, and that's just going to be natural log of 7. You could do that, but I'm going to just leave it as natural log of 49. And then minus 4/9. Now we just said 49 to the 3/2 is 343. And then what happens here? So this part is 0. And then the 2 minuses here will become a plus 4/9. Okay, so let's simplify that. So first of all, natural log of 49 is a separate term. It cannot be combined with the rest. So this part we are going to compute what that is, probably going to be some huge fraction. But here, you can't do that. The only thing you can do is just multiply and see if that turns out to be something better, which I don't think it is. So we're just going to say, okay, that's 686 over 3. That wasn't reducible. So then if you have natural log of 49, and then what is this? Well, let's compute that. So actually we have a negative here. Hi. And then we have plus 4/9. Okay, so in this case, I guess I got some nice number, negative 152. Okay, so let's put that in here and hope that I got it.